Question number 13. Calculate the concentration of H plus ion in a 0.62 molar NaOH. So the first rule is that you need to know that NaOH is a strong base, where the concentration of a strong base is actually equivalent to the concentration of OH minus. So, since you already know the concentration of OH minus here is 0.62 molar, but you actually want to calculate the H plus, so you can use Kw equivalent to concentration of OH minus times concentration of H plus. Remember, this Kw is actually a constant value. The value of Kw you need to always remember is 1.0 times 10 to the power of negative 14. So you just plug in this value 0.62. So you are going to calculate the value of H plus. So from here, H plus is equivalent to 1.6129 times 10 to the power of negative 14 molar. Question number 14. Determine the Kb of ammonia if the pH of a 0.30 molar of solution is equal to 10.66. So, from this question, you know that initial concentration is equivalent to 0.30 molar. Therefore, the pH is equivalent to 10.66. So from the pH, what you can actually calculate is that pH is equivalent to negative log H plus. So, since your pH is 10.66, you can actually calculate what is the H plus. So, your H plus is equivalent to 10 to the power of negative 10.66, equivalent to 2.1877 times 10 to the power of negative 11. Voila. Right. So now, since you are going to calculate the Kb, so you actually need the concentration of OH minus. So how are you going to get this OH minus? Same like the previous question, you need to use the Kw. So Kw is equivalent to concentration of H plus times concentration of OH minus, where Kw is a constant value, which is 1.0 times 10 to the power of negative 14. So since you already know the concentration of H plus here, so you just plug in this value 2.1877 times 10 to the power of negative 11, so times the concentration of OH minus. So you can easily get this OH minus. So from the calculation, you should get 4.5710 times 10 to the power of negative 4 molar. Okay, so this is the first half part of the calculation. And then you need to look back at the question. So determine the Kb of ammonia. So do the chemical equation. Ammonia is NH3. So for ammonia to dissociate, you need to add water to it. So plus H2O, it will dissociate to become NH4 plus OH minus. So it's a clue for you. This ammonia cannot dissociate independently without the addition of water, because you are aiming to get this OH. So if you just use ammonia, there's no way you can get the O over here. So definitely you need to add water here. So since you already have this chemical equation, you can directly do the ICE diagram. ICE. So remember, in ICE diagram, the water can be omitted from this calculation. So from the question, it states that the initial concentration is 0.3. So initially there's no dissociation occurring, so 0, 0. So here negative X, positive X, and positive X. So at equilibrium you will get 0.3 minus X, X, and X. Okay. Okay, from the ICE diagram you can calculate the Kb equivalent to whatever in the product. So it will be concentration of X divided by 0.3 minus X, but your X is being calculated before, which is the concentration of your OH minus. So here, this is the OH minus. So you can say that your X is actually equivalent to 4.5710 times 10 to the power of negative 4. So you just plug in this value, 4.5710 times 10 to the power of negative 4 square over 0.3 minus 4.5710 times 10 to the power of negative 4. You should get your Kb equivalent to 6.97629 times 10 to the power of negative 7.